G'day team! Today I'm going to talk through the lighting system I originally built for the haunted houses for the Lunar Dark Festival, run at Melbourne's Luna Park every year, and then modified for use in refurbishing the 90-year-old ghost train. When first planning out the Lunar Dark haunted houses, I came across a problem with just about every light I could purchase or rent. They wanted to cast light onto objects. They were really into it, just putting out as much light as they could with as little power and heat as possible. In every other application, this would be exactly what I'd want with a light. For a haunted house though, yeah, I wanted small amounts of light that I could direct very specifically so as to draw attention to important things while still keeping spaces dark and scary. Very important if you want to hide actors in spots where they can jump out and say boo. After an embarrassingly long amount of time spent testing different lighting solutions, the answer ended up being the lowly 5mm LED. You know, the one that you get in those starter Arduino kits. The tiny little light that you make flash to show that you've got a program running. Cheapest chips and rarely used for anything exciting or useful. Anyway, we use them to light multiple huge installations, and you can too. The light tube consists of a few key components. The main body has a bottom curve and holes to allow it to be easily placed and zip-tied to temporary fences, which are used a lot in haunted houses. It's also got ribs along the body in case it needed to be zip-tied in different orientation. Zip ties being one of the major construction elements in temporary haunted houses. For the ghost train, I also made a more permanent mount that is screwed onto the back of these zip ties holes. The inner tube of the light is what houses the electronics. This is separate so they can be easily slid in and out for construction and maintenance. The light also has a front lid, which has a space which can hold a lens which allows us to focus the light at different angles. These I bought on AliExpress and are amazingly cheap for how useful they are. The front of the lid can also be swapped out for a larger funnel-shaped lid, which allows us to slot in a 3D printed gobo of any design we might want, which itself has a screw-on lid for easy access. The gobo attachment also has space for a focusing lens of our choice. All parts of the light are 3D printed and are designed to be printed easily in large sets with no supports. Now, the lights for the haunted house and the ghost train ran on 12 volts, my preferred working voltage and a pretty good standard. If you decide to go with something different, good for you. However, for this video, I'm going to talk about the different ways of putting together the light electronics, assuming we're working with a 12-volt power supply. In my lights, there are 3 electronic components. Number 1, the LED itself. This can be any color you want, which is useful for when you want to build a variety of feeling in your scene, although I find that a nice warm white is the most flexible for spaces. Number 2 is the resistor that will soak up the unwanted voltage from our power supply and make sure our LED won't burn out. Number 3 is a capacitor to smooth out any bumps or flickers in our power supply that may damage the LED. For small builds, this part may not be appropriate, but in both the ghost train and the haunts, there is generally a few kilometers of wiring, so I like to make sure I have some extra protection for the lights. For those who don't know, a capacitor is like a little battery. As electricity starts to flow across it, it'll charge itself up, and as the electricity stops, it'll discharge. Very useful for smoothing out signals or catching variations in the electrical supplies. A capacitor runs in parallel to our LED and resistor combination, so you can choose to include it or omit it, and it won't change any of the other electronics we'll be using. For our project, we'll be using this 16 volt 22 microfarad capacitor I really just had to hand. If you haven't done electronics before, calculating the appropriate resistor to pair with an LED to give it the correct power supply can be a bit daunting, and the method might not feel entirely logical. That's okay. You don't need to have a flawless understanding of it. Just know the steps so you can copy them, and it'll work every time. Let's start by looking at what the person who sold us the LED says it wants. We need to look at the voltage and the current, which in this case is 3 volts for the voltage and 20 milliamps for the current. both pretty standard for LEDs. To figure out what resistor we need, we have an equation, which is R for resistance is equal to V for voltage over I for current. Don't ask me why it's I for current. Engineers just love the letter I and use it for everything they can. In this equation, the voltage right here is how much voltage we want the resistor to use up. So we can figure that out by looking at the voltage coming in, which is 12 volts, minus the amount of volts we want the LED to have, which is 3, leaving us with 9 volts. That leaves us with one value left to find, the current, I, which is pretty easy because it's the same current as we've been given here, 20 milliamps. However, just to be sneaky, the I in this equation, it doesn't want milliamps. It just wants amps. So 1 milliamp is equal to 1/1000 amps. So to look at I, we need to take the number we were given, which was 20, and divide it by 1000, meaning that in this case, I is equal to 0.02 amps. So let's look at our final equation. R is equal to 9 volts over, or divided by, 0.02 amps. If we punch that into the calculator, we can see that the resistor we want to use to soak up those 9 volts when 20 milliamps is running through it is a resistor of 450 ohms. Now, the value of the 3 volts for the LED up here was described as nominal voltage, meaning we can err a little bit on either side and the LED will be okay. That's pretty useful because they don't make resistors with a value of 450 ohms, or at least not normally. Now, you can look up standard resistor values online, but I'll spoil it for you in this case and say the two closest values that they come in is 430 and 470 ohms. Now, let's have a look at our previous equation backwards. So the amount of voltage we would use up if we had 0.02 amps running through multiplied by 430 ohms, it would drink up 8.6 volts, meaning our LED would get 3.4 volts. If we had the 470 ohm resistor, it would drink up 9.4 volts, meaning the LED would only get 2.6 volts. Now, they're both off by 0.4 volts, but the LED will be a little happier with a little bit more power than less. So in this case, we're going to go with our 430 ohm resistor. Well done, we did it. Now, there's no paint to dry in this particular project, but it's still a good time to go make a cup of coffee. Now, to wire all this up, there are 3 methods I like to use. The mass manufacturing method, the bespoke method, or the cheap method, all of which are pretty good. The mass manufacturing method that I use, which saved a huge amount of time, as I had to churn out loads of these little guys for my various projects. The method cuts down on fiddly wiring by having all the pieces mount to a PCB, while using 3D printed jigs to bend everything into appropriate shape. I got these PCBs made up at JLC PCB for fairly cheap, and while they're the most basic design you might ever see, it really saved a huge amount of time in putting together all of these lights. To assemble, first we're going to press the LED and the resistor into shape using their associated jigs. Now we take our LED, slot it into place in our PCB, and then put it upside down in our little LED and PCB holder. This makes sure that the LED is soldered into place at the correct height. Once soldered, we clip off the XX LED legs and slide the resistor into place. Now, the resistor doesn't have to be at a specific height, so we can just bend its legs out and then you can solder into place. If you're going to be using a capacitor, now is the time to slot it in. taking careful note of the polarity to make sure it goes in the right way. Just like the resistor, we just bend these out to hold it into place and then solder it down. For the wire, we trim just a bit of the wire, and then what I like to do is put a little bit of solder onto the ends of the wire just to hold it together so it doesn't fray apart when I put it into place. Then take the wire and put it through these little holes on the PCB, making sure to check the polarity, black being negative. Now, to make sure that any pull or stress on the wire doesn't hurt our connection, we can thread our wire through these holes in the back of the PCB. This will act as a stress and strain reliever, making sure that any time someone or something pulls on the wire, the force is not translated through to our connection. And now the PCB simply press fits into the inner tube and it's done. The bespoke method is a little bit slower, but it also means you don't have to order in any PCBs, which are more expensive at lower numbers. For these, everything has to be cut and assembled by hand. To start with, we're going to solder the resistor onto the LED. The best way to do this is to bend a hook into the positive leg of the LED and another hook into one of the legs of the resistor. Now, you can put the resistor either side of the LED, positive or negative, but I like to make sure whatever I'm doing is consistent across all my objects. That way, I can easily tell at a glance which side of the LED is positive and which is negative. Now with this done, I like to strip a bit of the end of my wire so I can then twist up the ends and fold them into hooks. Now I can twist the wire around the appropriate ends of the LED and hook them over to hold them in place. If you're going to use a capacitor, now is the time to put in some hooks and connect it. Once again, being very careful to know which way the polarity is going. Ugly, but it gets the job done, and no one will ever really look at it, except for us. Now, we tape up to cover what we've done, and so none of the components can touch each other and short out. Now, we can hide our abomination unto God by putting it inside the inner tube. For this case, for strain relief, we want to have just a teeny loose little knot at the end. Now, as we can't press fit this in this case, we'll just put a little bit of hot glue to hold everything in place. So the cheap method is a bit like the bespoke method, but much easier. In this case, rather than sourcing an LED and resistor separately, we buy a 5mm LED that's already got an attached resistor to make it 12 volt appropriate. As LEDs are so dang useful in so many applications, there are lots of places selling them that already have inline resistors to make them perfect for all manner of voltages, which can save some time when putting them together. So from this one, we take our wires from our 12 volt LED, trim away about 1 centimeter to expose them. We take our wire, trim away the same amount, and then making sure to line up our voltages correctly, black often being negative and red often being positive. Now we just twist them together. Now we twist them over into our little hooks and put the same hooks in our capacitor. Now once again, being careful of the polarity, we hook them onto each other and then we solder them together. Much cleaner than the bespoke method. And now we just hide up what we've done using some electrical tape. Perfect. Now once again, we put a little knot at the end of our wire to act as strain relief. Don't put it too tight. And then we glue our unholy mess into the inner tube. Now we have our 3 LED inner tubes made using our different methods. They all slide in just the same into our main tube, and then we can have our lens and lid screw it into place. Now it is ready for temporary mounting in our haunt. If you want a more permanent mounting, you can use one of our mounting jigs along with an M3 bolt and a nylock nut. You also have a little inner spacer tube just to make it more M3 appropriate. And if you want some cool effects, we can take off our front lid and replace it with the gobo lid. We'll then take our 3D printed gobo, we can then screw into place to create all sorts of cool effects. To connect the lights up to a power source, there are lots of different options that all have their pros and cons. For the haunted houses, because I wanted to be able to put them up and take them down as fast as possible, I bought a bunch of connectors online and soldered one end to the LED wires and the other end made a little breakout board. This allowed me to plug them in and out as fast as possible, but it took a lot of time to make before the installation of the haunted houses, and it meant I had to buy a bunch of connectors. For the ghost train, where I could install them more slowly and wanted them to stay forever, I used some screw terminal blocks, which can be picked up from any good electronics hobby store really cheap. They're a bit slower to set up on the day because to attach a light you have to use a screwdriver to tighten each terminal. But it is a great solution for a longer term setup, as well as being an off-the-shelf part you don't have to make yourself. Choose a method that's appropriate to your use case. Now, if you want your lights to have effect, you can swap out the front lid for a gobo and cast light with patterns. Should you want your light to have a bit more life and feel less static, there are endless amounts of effect LEDs you can find, such as these cool white flickering ones, which give a harsh and foreboding atmosphere. There's lots of fun to be had, and good lighting can really change the whole mood of a space. All the files for this are on my MakerWorld page. Try it yourself.